Building multi-tenant applications, where each user sees only their own data, shouldn't require reinventing authentication for every endpoint. You'll see how to extract tenant and user information directly from JWT tokens in a FastMCP tool, then use those claims to filter data, all while keeping your function signature clean and your security logic centralized. The pattern handles missing tokens gracefully and demonstrates how token claims become actionable context in your tools. From FastMCP, import FastMCP. From FastMCP server dependencies, import getAccessToken. MCP equals FastMCP. Name equals multi-tenant demo. At MCP, tool. Async def get tenant data, resource ID, SDR, dict. Get tenant specific data using token claims. Token, access token none equals get access token. Hash extract tenant ID from token claims. Tenanted equals token, claims get tenant ID, if token else none. Hash extract user ID from standard JWT subject claim. Userid token, claims get sub, if token else none. Hash use tenant and user info to authorize and filter data. If not tenanted. Raise value error, no tenant information in token. Return. Resourced, resourced. Tenanted, tenanted. Userid, userid. Data, F tenant-specific data for tenanted. This demonstrates the context-aware multi-tenancy pattern in FastMCP, where tenant isolation and user context are dynamically injected into tool execution. The pattern uses authentication tokens as the source of truth for tenant and user identity, automatically propagating this context through dependency injection. What makes this distinctive is how it decouples identity management from business logic, letting you focus on data access rules rather than token parsing. The approach works by treating the access token as an ambient context that's available anywhere in the request flow. FastMCP's dependency system extracts and validates the token once, then makes standardized claims available through simple function calls. This creates a clean separation where authentication concerns live in the framework layer, while your tools remain focused on their core logic using the provided context. This pattern solves the common problem of multi-tenant data isolation without requiring manual request inspection. It's particularly valuable for SaaS applications, internal tools with departmental access rules, or any system where data visibility depends on the requester's identity. The trade-off is that your tools become dependent on the token structure, so claim names like tenanted must be standardized across your authentication system. Let's break it down. From FastMCP, import FastMCP. From FastMCP server dependencies, import getAccessToken. Imports FastMCP, the core framework for building AI-callable tools, and getAccessToken, a dependency that extracts JWT claims from incoming requests. This establishes the foundation for multi-tenant authentication, where each request carries tenant-specific context. MCP equals FastMCP. Name equals multi-tenant demo. This initializes the FastMCP server instance named multi-tenant demo. This central object registers all AI-callable tools and manages their execution, while the name helps identify this specific service in logs and monitoring. At MCP, tool. Async def get tenant data, resource ID, SDR, dict. Get tenant-specific data using token claims. Token, access token none equals getAccessToken. This defines an AI-callable tool using FastMCP's decorator pattern. The @MCP tool decorator exposes this function to AI models, while the type hints and docstring automatically generate the tool's schema. The function starts by retrieving the access token from the request context, which contains tenant-specific claims for multi-tenant authorization. This is the standard FastMCP pattern for secure, tenant-aware operations.
Hash extract tenant ID from token claims. Tenanted equals token. Claims get tenant ID. If token else, none.
This extracts the tenant identifier from JWT token claims, implementing multi-tenancy at the authentication layer. The conditional handles missing tokens gracefully by returning none, while the get prevents key error if the claim doesn't exist. This pattern ensures tenant isolation before any data access occurs.
Hash extract user ID from standard JWT subject claim. Userid token. Claims get sub. If token else, none.
This extracts the user identifier from the JWT's standard, sub, claim, which represents the authenticated user's unique ID. The conditional handles missing tokens gracefully by returning none, preventing attribute errors while maintaining the function's contract to return a dictionary. This follows the common pattern of safely accessing nested claim data in JWT validation.
Hash use tenant and user info to authorize and filter data. If not tenanted, raise value error. No tenant information in token.
This is a critical authorization check that enforces tenant isolation. By raising an error when no tenanted exists, it prevents unauthorized cross-tenant data access, a core requirement in multi-tenant architectures. The pattern ensures every request carries valid tenant context before processing.
Return. Resourced.
This returns the requested resource ID in the response payload, maintaining data consistency between the request and response. Including the original identifier enables clients to correlate responses with their initial requests, which is critical for multi-tenant systems where multiple resources may share similar data structures. Multi-tenant isolation pattern. The tenanted claim in JWT tokens enables FastMCP tools to automatically scope operations to specific tenants without explicit parameter passing. While they're at MCP, Tool Decorator handles schema generation and AI exposure. Missing tenanted claims will cause silent authorization failures rather than explicit 403 errors, making debugging harder when tokens are malformed. Always validate critical claims early and fail fast with clear error messages.
The decorator that knows no tenants governs all tenants.